Welcome to Lesson 82, Algebraic Simplifications. So, there are 3 rules of algebra that stand above all the rest of them. 2 of the rules cannot be used unless an equal sign is present, and that's the first 2. And that is basically, it boils down to our rule, whatever you do to one side, do to the other. Whether it's addition or subtraction, multiplication or division, whatever of those 4 main operations, if you do it to one side, do it to the other side. And it breaks down into 2 basic rules. The first rule is that the same number can be added or subtracted from both sides of an equation without changing the solution. And to give you an example of that, if I have 3 plus 1 equals 4, if I subtract 1 from both sides, I get 3 is equal to 3. So the solution is the same. The equation is still balanced as long as whatever I do to one side, I do it to the other side. I could do the same thing with multiplication here. I could multiply this side by 2, and I can multiply this side by 2. That would be 6 plus 2 would be 8, and 4 times 2 would be 8. So it would balance that as well. I could also divide. If I said 3 plus 1 is equal to 4, and I divided both sides by 2, I would get 4 divided by 2 is 2, and 4 divided by 2 is 2. So as long as you maintain the equilibrium of the equation, then the solution is not going to change. The values and the relationships of the equal sign will still remain true, which is the whole point of an equation. It's like a scale. You want everything to balance out on both sides. So those 2 rules are summed up in whatever you do to one side, do to the other side. That's our main rule. So let me put our third rule up here. So the third rule of algebraic simplifications is that the denominator and numerator of an algebraic expression can be multiplied or divided by the same non-zero number without changing its value. So let me explain what I mean by that. What I mean is, let's say we take the number 1. It's basically, if we turn into a fraction, it's 1 over 1, because we know we can turn any whole number. Actually, I'm going to change that. Let's take 2. Let's turn that into a fraction, 2 over 1. Any whole number can be turned into a fraction by putting it over 1, right? So this is our fraction, 2 over 1. It's really the whole number 2, because we know if we divided, because a fraction is just a division problem, if we divided by 2 by 1, our answer would be 2. Right? We know that. If I were to multiply this by, let's say, 5 on the top and 5 on the bottom, I would get 10 over 5. 10 divided by 5 is what? It's 2. 2 is still equal to 2 regardless of what number we multiply it by, as long as we multiply it by the same number in the numerator and the denominator, the value of the fraction is going to remain the same. That is what helps us whenever we are trying to get a common denominator. We're trying to make sure that all of the fractions have the same denominator. We can multiply as long as the number on the top and the bottom are the same. We don't have to multiply each fraction in the equation or in the expression by the same fraction. We just have to multiply each fraction by a fraction that has the same number in the numerator and the denominator. And the reason this is true is because ultimately 5 over 5 is equal to 1. Think about it. 5 over 5 is equal to 1. And we know from our elementary math the identity property of 1, which says, the identity property says that anything multiplied by 1 equals itself. So that just means 2 times 1 is equal to 2, right? 3 times 1 is equal to 3. Well, what we did up here, technically, we said 2 divided by 1, that's 2 times 5 divided by 5, that's 1. The answer is 2. That's what we did here. We just changed what it looked like, not what its value was. So because of the identity property of 1, we're able to take that and turn it into a fraction with the same number on the top and the bottom, which equals 1, and multiply any number, any fraction we want to change the denominator to anything we want without changing the value of the fraction. For instance, let's do another one. All right, I'm going to say 3/5. And I'm going to multiply that by 4/4. Now remember, 4/4 is just 1. It's just 1. So we're saying 3/5 times 1 is equal to 3/5, right? When I look at these numbers, 3 times 4 is 12. 5 times 4 is 20. Is 12 3/5 of 20? Yes, of course it is. We know because I can take this same fraction and divide it by 4/4. 12 divided by 4 is equal to 3. 20 divided by 4 is equal to 5. This is enlarging the fraction. This is reducing the fraction. Multiplication is when we enlarge the fraction. Division is when we reduce the fraction. Okay, and usually we reduce the fraction for the sake of having the smallest fraction to make our math easier. And we enlarge a fraction to find a common denominator to make our math easier. Both of those things are used to make our math easier so that we can see the answer better, especially if we're doing mental math. And typically, if we're using fractions, we're doing mental math. Calculator math tends to use decimals, which, defeats the purpose of a fraction. All right, so keep that in mind. These numbers right here, they equal 1. So we are multiplying and dividing by 1. So the value of our fraction remains the same. Isn't that kind of neat? I kind of like that. It kind of comes full circle, and we're understanding why we learned our ones times tables now. It's to cement that idea of the identity property once we get to algebra. All right, we understand why this works because of our ones times tables. We know that the value remains the same when we multiply or divide by 1. Okay? All right, I think we have a practice problem, so let's try it. Now, these are complex. These are not going to be as easy as our examples. 82.1 says to simplify this. A over 1 plus A over 1 plus 1 over X. Miss Tracy, that is not what we just did. I know. We're going to normalize these fractions and simplify them by using what we know about transforming fractions in order to get there. So first we're going to start with the innermost denominator. This innermost denominator is going to be the smallest one, right? The bottom denominator. So 1 plus 1 over x. So we just bring it over to the side and we write it out. 1 plus 1 over x. We need to find a common denominator. Turn this into a fraction so you can see it better. We need a common denominator. 1 times x is x. Right? So we need to turn this into an x. So what we're going to do is we're going to multiply this fraction right here by x over x. It doesn't matter what x is, because we know the same number over the same number is still equal to 1. This is still 1. So when we multiply this here and we get x plus 1 over x, because now that this has an x, this would be x over x, we get x plus 1 over the same denominator. Now we can take this and replace this entire thing. So now we have a over 1 plus a over x plus 1 over x. Guess what we have now? We have a new denominator, and we have another one of these little things. So before we go any further, we're going to simplify this. What is this? This is simply a fractional division problem. So we have a over x plus 1 divided by x. Now, if you're smart, and I know you are, you're going to see that we can turn that a into a fraction, a over 1. What do we do when we have a fraction divided by a fraction? We keep it, change it, flip it, right? So we turn it into a over 1 times x over, I should probably use a dot because all these x's are going to be confusing, x over x plus 1, right? We kept this, we changed this to multiplication, and we flipped our fraction. So now we have ax over x plus 1. That's our new fraction. So we can rewrite this, a over 1 plus ax over x plus 1. Now we're back where we started with this. So now we're just going to find another common denominator. So we take this over here and we say 1 over 1 plus ax over x plus 1. We need to have a common denominator of x plus 1. So we're just going to multiply x plus 1 over x plus 1 times 1 over 1. Because it doesn't matter. It doesn't matter what x plus 1 is. If it's the same on the top and the same on the bottom, it's still equal to 1. So we're just multiplying this by 1. So now we have x plus 1 plus ax all over x plus 1. This x plus 1 came from multiplying x plus 1 times 1, right? So what we really did was this. Let me show you. I skipped a little step. So what we did was we multiplied this first, and we got x plus 1 over x plus 1 plus ax over x plus 1. Well, because these are the same denominator now, we just pushed it all together. X plus 1 plus ax all over x plus 1. All right? All right, so now this becomes our new denominator here. So a all over x plus 1 plus ax over x plus 1. Well, you see what we have now. It's the same thing we had up here. We have a number divided by a fraction. We turn that into a fraction. A becomes a over 1 divided by, we just write it as a number sentence so we can see it, x plus 1 plus ax all over x plus 1. Keep it, change it, flip it. A over 1 times x plus 1 over x plus 1 plus ax equals ax plus a over x plus 1 plus ax, and that would be your final answer. It's more tedious than it is hard. You're just going to keep repeating these two steps. The first step, common denominator. You find the common denominator of this bit right here. And then you replace it, put it back in. Then when you have a number divided by a fraction, you keep it, let me see if I can actually spell that. You keep it, change it, flip it, KCF. So keep it, change it, flip it for the next step. And then you immediately go back to a common denominator. So you go back to step 1, common denominator. Then you go back to the next step. Keep it, change it, flip it. right? I'm going to write it out up here just for the sake of those who don't know it. Keep it, change it, flip it. So you're just repeating those steps. Common denominator, keep it, change it, flip it. Common denominator, keep it, change it, flip it. That's typically what you're going to do over and over, and depending on how many of these you have built within the same problem or the same fraction. So just look for the clues. Your first clue is if you have an operation in the denominator, then you are going to use a common denominator step. If you have a number or a fraction divided by another fraction, then you're going to turn that into an expression, keep it, change it, flip it. Once you turn that into an expression, well, then you have to find another common denominator if there's an operation here. So just keep looking for those clues and keep simplifying using those two methods, common denominator and keep it, change it, flip it. Let's do 82.2, and then we are done with lesson 82. All right, so 82.2, we have b all over a plus c all over x plus 1 over y. So I see an operation and a regular fraction. So you have a regular fraction, we know this is common denominator time. So x plus 1 over y, I need to multiply by y over y. We put this over 1 and turn it into a fraction. So I need to multiply to get a common denominator. So that's going to give me xy plus 1 over y. So now I replace this with this. So b all over a plus c over xy plus 1 over y. All right, so now I see in my denominator, now that I've replaced it, I have a number divided by a fraction. So now I'm going to keep it, change it, flip it to turn this back into a simplified fraction. So we would turn this into c over 1, and then I would multiply, and I'm going to go ahead and flip it so I can save myself some time, y over xy plus 1. That's going to give me cy over xy plus 1. I'm going to replace this here. So now I have b all over a plus cy over xy plus 1. Again, I have an operation with a fraction in my denominator, so I have to turn this into a simplified form. So a over 1 plus cy over xy plus 1. Take my denominator, multiply it on the top and the bottom times my whole term, and then that gives me xy plus 1 plus cy all over xy plus 1. Now I can take this and replace the entire thing. Oh, I'm sorry, I left off my a. It's a xy plus 1. Is that right? No, that's not right. Sorry. I goofed just a little bit because a has to be times both of these terms. It'll be axy plus a plus cy. There we go. Now that's right. So now I'm going to replace this here with this. This is my new denominator. So now I have b all over axy plus a plus cy all over xy plus 1. Now I have a number divided by a fraction. Keep it, change it, flip it time. I'm going to flip the bottom fraction. That's going to be xy plus 1 over axy plus a plus cy So bxy plus b over axy plus a plus cy. Let me double check the book. And that is exactly what the book has. We got it right. Yay for us. That will be your final answer. All right. So again, common denominator, keep it, change it, flip it. Common denominator, keep it, change it, flip it. And we got to our final answer, our most simplified answer. And that is how you do it. All right. That's all we have for lesson 82. If you have any questions, please feel free to message me, and I will see you in lesson 83.